Hello, everyone. Welcome back to our videos on section 1.3, the derivative at a point. And remember, before continuing this video, make sure you've had an opportunity to look at this example and exercise number 1 on your own first. Try to get as far as you can on a solution. And when you're ready, continue watching. All right, so number 1 says, let f of x equal the function -7 plus 6x minus x squared. And you can see this graph or this function drawn graphically here on the right. And now it's asking us to use the limit definition of the derivative to calculate the derivative of f at 4. Then it asks what this number represents geometrically. So first, let's take a deeper look at our curve to understand what it is we are going to compute. So if I identify x equals 4 on my horizontal axis, I have this point here on my graph. And let's recall the derivative of my curve at that point is the slope of the tangent line at that point. So here's my tangent line. I could call it T for tangent line. So this f prime of A is equal to the slope of the tangent line. We'll call it T at x equals 4 on my function f of x. So we can first just ask, well, what do we think the slope is going to be? First, we could ask, is it going to be positive or negative? You might see it slopes downward, left to right. So our slope is going to be negative, should be. And then we can get a sense of what the value should be. So we can maybe pick 2 points, okay, about this point and this point. So that's about here at 3, 3. And this point is about here at 5, -1. So then the slope should be about difference in y's. So that'd be 3 minus -1 over the difference in the x's, 3 minus 5. So that's going to be about 3 plus 1, because we have 2 negatives canceling out, over 3 minus 5, which is going to be 4 over -2, which is -2. So the slope of our tangent line at that point should be about -2. So now let's actually calculate that slope or that tangent line using the limit definition. So just recall the limit definition of the derivative of f at a point A is equal to the limit as h goes to 0 of f of a plus h minus f of a. So in our case, we're just going to fill in our numbers. So in our situation, A is equal to 4. And I should have had that here as well, because I'm using x equals 4. So at A equals 4, we have f prime of 4. And it's really good to write it all out so that you get practice memorizing this limit definition. F prime of 4 equals the limit as h goes to 0 of f of 4 plus h minus f of 4 all over h. So take a moment, pause the video, and check your work at this point. When you're ready, we can carry on to the next step. So we have our function f up here. So now what I'm going to do is just input 4 plus h into x, and then subtract inputting 4 into x. So that's going to look like the limit as h goes to 0 of -7 plus 6 times 4 plus h minus 4 plus h squared minus, so what I just computed was this first part. And I'm going to highlight it so we can keep it all separate. So what I just computed was this f of -4 plus h Now I'm going to subtract 4h. Sorry, f of 4. So now I'm going to subtract f of 4, which is -7 plus 6 times 4 minus 4 squared. And I like to use a lot of parentheses because when I'm subtracting this entire term, f of 4, I want to make sure that that negative symbol goes across everything in that f of 4. So I'm going to divide by h. And now we just get a lot of algebra. So it's important to just take a deep breath and take it slow. So what I'm first going to do is just compute this number here. So f of 4 is a number because I'm just using numbers in here. I don't have any h's involved. So I'm just going to do that to the side first. A little star here. So f of 4 is equal to -7 plus 6 times 4 is 24 minus 4 squared is 16. So I can compute that. -7 plus 24 is going to be 17 minus 16 gives me 1. So I can replace this. This is just a little side note. So this is going to be equal to, I'm continuing my limit here. So the limit, h goes to 0 of -7 plus 6 times 4 plus h minus 4 plus h, all of that squared, minus 1. That whole green box became -1 over h. So now we can continue to expand this and therefore cancel out some things. So that numerator becomes -7 plus, so I'm going to bring that 6 into the 4 and the h, plus 24 plus 6h minus, and now I need to FOIL out this guy. So when I do that foiling, I get 4 times 4, which is 16, plus 4h, which is 8h, plus h squared, minus 1, all over h. And now while you're watching this video, if I do something too fast, you can always pause and work it out on your own. It's going to be a great way to check my work and to follow along. All right, so now what I'm going to do is bring this negative into this entire chunk here. So it's going to become the limit as h goes to 0 of -7 plus 24 plus 6h minus 16 minus 8h minus h squared minus 1 all over h. So now let's take a pause and see if we can clean up that numerator at all. So I'm going to combine like terms. So I see that I have a 7, a 24, a 16, -16, and a -1. So those are all just numbers, so I can combine them. And we see what happens is this -7, -16, -1, that becomes -24. And then I have a positive 24. So all of those numbers cancel, which is just beautiful. So now what do I have left with but the limit as h goes to 0, and I'm going to start a new page here because I'm writing a little too big. So that's going to be, we continue here, continue to simplify the limit as h goes to 0 of positive 6h minus 8h minus h squared all over h. So we still have some like terms in that numerator. We have a 6h and a -8h, so we can cancel those terms. So further, I get the limit as h goes to 0 of 6 minus 8 would give me -2h minus h squared all over h. So now what we see is that both terms in that numerator, -2h and h squared, has an h in it. So we can factor that h out of each term to get the limit as h goes to 0 of -2 minus h all times h over h. So notice we can do that. We just factor out an h of each term. So we get -2 minus h times h, because if we distribute that h back in, we get our original. And the reason why we did that is because now we can cancel that h out of the numerator and denominator. We're just multiplying h in the numerator. So by dividing by h, those two h's cancel. So now what are we left with? Well, we're left with the limit as h goes to 0 of -2 minus h. So now we can take a step back and analyze that. We see now that there's no problem with plugging in h equals 0, meaning the limit of -2 minus h, as this h gets really, really small, close to 0, this entire number just goes to -2. So this limit is equal to -2. So now we can just take a step back at what we just did. Well, in all of this work, we were computing the derivative of f at 4. So what we've just found is that the derivative of f at 4 is equal to -2. Awesome. Great work, everyone.